Let me briefly introduce the natural language programming things that we've done. We have tried out on some IQ tests, okay. And we've done a space nuclear reactor. That's the huge one. That's a very real one. It's about like $100,000 contract by General Electric and the Lockheed Martin, the world's largest weapon manufacturer. And the ball drop, ball bounce, ball drop, ball throw. You can determine price. It does some elastic collision, energy mass conversion, like the Einstein equation. The ball drop is the Newton's gravitation acceleration. This is energy, so they can easily done these two problems. And flow network, that's very important for our nuclear engineers. Non-natural ball drop. It's much harder to do it than natural language. And neutron transport and play golf. It shows how we can simulate golf play. Anyway, let me just finish off by doing this space nuclear reactor. Okay. So it has 3 sections. It takes like a quite a bit. It's maybe 45 seconds to click off. So let's just go to the third one and click the last 1/3 of the processing. Okay, so it's talking about alt matrix generation. Okay, all the yellow characters are input by the user, before we get it, and it's done. It's basically represent what the robot is typing. The software robot. So any alt matrix, yes. Any reshape rod, yes. Okay, it's the robot is really teaching a new novice engineer how to do the professional job. The number of rods on each side. This is totally put in according to a blueprint. Okay. Radius alt matrix. Okay, radial alt matrix. You have the value on the blueprint. So it's the input. The height of alt matrix. Select material for the rod. Okay. The median circle is something. Alt matrix rod thickness. Input, we have the height of our rod. No, it's not a conflict. Material thickness or next layer, there's no layer. So R boundary, input, number of R matrix from center, number of R matrix from center, no. More R rod, no. Submit. Okay. So we got it. Now we have modeled the space nuclear reactor as that's I modeled the SP100. Now this time it's the JIMO for Jupiter exploration. The first one is the Ronald Reagan's Star Wars. The second one, this one is George Bush's Jupiter exploration. It's obvious it's the anti-missile system, okay. Defense system. Cylinder sector processing. Okay, refractor gap. This is how we're going to check our plot. Core height with we're feeding on the geometry of the reactor now. This matrix process, we have to feed in boundary thickness, fluid length, barium oxide refractor height. Is a missile. Okay, all this is strictly coming out of the blueprint. Okay, no engineering calculation to avoid any kind of human errors. So we cut 2 rows and we're going to drop it and raw pitches. Okay, this is all. Okay, this is the drawing that we made. Okay, we actually very painstakingly draw this. Okay, the initial drawing actually is everywhere it's this, like this. Okay, but now when the logging manager came to my place and want to make a change to see how powerful the program is, he requested that I change this to a water hole. Okay, so I tried. I didn't know whether it's going to work. I tried, and while just like in less than 3 minutes, okay, we got it. Okay, this is for human to do this change. Okay, in a real program, probably 3 months, not 3 minutes. Okay. So anyway, this is the natural one. Look at all the original graph still showed up. Okay, and we feed this into this code called MCMP, Monte Carlo analysis program. Okay, it's Monte Carlo, just the most detailed calculation you can have in the world, because it follows every neutron. Okay, it could be used for our pandemic analysis. Okay, and the delayed action, all kinds of things. Okay, what kind of amount of action? So it's pandemic. We can analyze to death with Monte Carlo program. Anyway, this is the one that is. I give a scale factor, horizontal view. Okay, this describes all the things that we try to investigate, and the full system. Okay, but okay, this one. Look at this one. This is the one that drawn out by MCMP. Okay, we feed in the data, then we ask, what did you see? And there is what they see. Okay, all the various material, whatever. Okay, digest and feedback. Then we plot it for the value that it sees, and it clean up everything. Okay, this geometry, what it sees, it doesn't see this kind of things. It has to get it so that the program will accept the input data. So everything, this is the real reactor basically. Okay, as far as software guys goes, and this is the reflector area. Okay, and the vertical view, that's just the all messed up. Okay, it's looking from the side, and all the bundles. Okay, the bundle cells we need to look at, because it's painstaking to draw them. Okay, once we draw it, we got to check them all out on the to see if there's any glitches. Okay, that's what so ROBACUS can do anything from pandemic to space wars. Okay.